Experiment number 7 from Design and Analysis of Algorithms Laboratory is to implement Dijkstra's algorithm for a given weighted connected graph and find shortest path to all other vertices from a given vertex. So in this program we have defined a class called as Dijkstra's and a single dimensional array distance with a capacity to hold 10 integer numbers is used to store minimum distance values from a given source vertex, and a single dimensional array path, which is also with a capacity to hold 10 integer numbers, is used to keep track of a distance via which vertex the given vertex was reached. And then we have a one dimensional array called visited with a capacity to hold 10 integer numbers, which is basically used to keep track of which all vertices have been visited so far. And then we have a member function called as solve, to which we pass three parameters. One is a two-dimensional array A, which is nothing but the weighted matrix or the adjacency matrix for the given graph, and S is the source vertex from which we want to find the shortest path, and then N stands for the total number of vertices in the graph. So initially no vertex is being selected, so therefore the variable selected vertex is set to -1. And then initially we set all the vertex distance values to infinity, and we also set the path from which the vertex reaches any given vertex also to -1. So therefore the distance matrix as well as the path matrix, the distance matrix is set to infinity, and the path array is set to -1, because initially setting path from which vertex any given vertex is reached is nil. And then after iterating in the for loop, distance of S is set to 0, so which says that it is distance to the source vertex. So distance to the source vertex is always 0. So now iterating through all the vertices in the for loop, where I ranges from 1 to n, that is through all the vertices, we initially set the minimum value of the vertices to infinity. So therefore min is set to 99. So we assume that infinity is now replaced by a number 99 in the program. And then we have a for loop wherein v ranges from 1 to n. V is nothing but the vertex. So here the current vertex v's distance, current vertex v's distance, if it is less than minimum and the vertex v is also not visited, that is visited of v is equal to 0, then we change the minimum value to the distance of reaching v, right? So the new minimum distance min becomes the vertex v distance, and the current vertex v now becomes the selected vertex. So therefore min is equal to distance of v, and the selected vertex is assigned the value of the current vertex v. So this is done for all the vertices in the given graph. So setting a selected vertex as visited, in order to set a particular vertex as visited, what we do is, in the visited array for the selected vertex we set its value as 1. And then we have one more for loop wherein we try to apply relaxation, where we try to traverse through all the vertices ranging from the first vertex to the nth vertex, checking for the distance. If the distance from the selected vertex plus the distance from the selected vertex to a vertex traversing to V, if it is less than the distance of vertex V and the selected vertex is not the same one as the vertex traversing to, and the vertex traversing to it is also not yet been visited before. So in that case what we do is we try to update the distance of V. So the distance of the vertex traversing to with the relaxation formula, and set the path of the vertex V from the selected vertex. So the relaxation formula is distance of V, which is equal to distance of selected vertex plus the distance between the selected vertex and the vertex V from the adjacency matrix A, and path of V is set to the selected vertex. So once this is done, we have one more method declared known as path, which takes two parameters. First one, V, stands for the vertex to find the path for, and S is our source vertex. So this method tries to find path for a given vertex, that is from which vertex to which given vertex was reached. So if path of V is not equal to -1, then we again make a recursive call to path of V from the source vertex S. So if the vertex that we are visiting is not equal to the source vertex, then we display the visited vertex using the system.out.print statement. And then coming on to the display function here, so it is now trying to display the shortest path between the source to all other vertices. So it takes two parameters. S stands for the source vertex and N stands for the total number of vertices. So for all, we are supposed to find out the shortest path to all other vertices. So therefore I ranges from 1 to n, the total number of vertices in the graph, and if I is not the source vertex, then we first print the number of the source vertex and then make a call to path function. So path function internally is trying to display whichever vertex is been visited. So you can see here in the path function on line number 57, we try to compare if vertex is not source, then we are trying to display the vertex that is been visited. So once the path is being displayed, and then the next line displays the distance from source vertex to the vertex V. So it is nothing but the shortest path between the source S to the remaining vertices are displayed in the for loop. So then we have a main method in the class. So we have created an object called as scan, which is of the type scanner class, and then we have declared an object called as Dijkstra, which is of the type class Dijkstras, and n stands for total number of vertices in the graph, and S stands for the source vertex, and A is nothing but the adjacency matrix to hold the graph values, that is the distances. Then we ask the user to enter the total number of vertices. So we read the value of n using the scanner object and its method next int, and then we have uh, uh, we have we are trying to read the content of the adjacency matrix or the weighted matrix or the cost of the or the distance between two vertices here. Using, as it's a two-dimensional array, we require two for loops wherein I ranges from 1 to n and j also ranges from 1 to n. So these lines, particularly from 86 to 89, read the content of the weighted matrix, and then we ask the user to enter the source vertex from where he would like to find the shortest path to all other vertices. Once it is done, we make a call to the solve method passing parameters the adjacency matrix A and the source matrix S and the total number of vertices in the graph given by n. So we call this method solve by using the object Dijkstra, which is object of the type class Dijktras. Once the path is found, we then try to display the path. So therefore we make a call to function display wherein we just pass the value of the source vertex and the total number of vertices in the graph. So it is again called with the help of the object Dijkstra. So after it we can close the scanner object. So now let us see how exactly this program runs. So now let us so it is asking for number of vertices. Let me say the number of vertices are 5. We'll now have to enter the weighted matrix. So if there is no edge, I will put a value 99 there to represent the value infinity. So A to A no edge 99, A to B is 3, and A to C no edge, so it is 99, 99. A to D distance is 7, A to E no edge, so it is 99. B to A there is a edge, value is 3. B to B no edge 99. B to C there is a edge 4 with a distance 4. B to D there is a edge with a distance 2, and B to D no edge, so 99. So similarly we'll fill the rest of the matrix. 99, 4, 99, 5, 6, 7, 2, 5, no edge, 4. The next one, 99, 99, 6, 4, 99. So now let us run it. Let us say the source vertex is the first vertex. So it says that the Shortest distance from vertex 1 to vertex 2 is 3, and from vertex 1 to 3 it is 7. So, and then distance from 1 to 4 is 5, and distance from 1 to 5 is 9. So the value is 3, 5, 7 and 9. So this is how the output of Dijkstra's algorithm looks like.